On the previous assignment, we had a problem that was 4p minus 1 in parentheses squared. What that literally means is that 4p minus 1 is being taken times itself. So I could rewrite this as 4p minus 1 times 4p minus 1. And then we could distribute the 4p times 4p, which is 16p squared. 4p times negative 1 is negative 4p. Negative 1 times 4p is also negative 4p. And negative 1 times negative 1 is positive 1. And then simplify by adding the like terms in the middle. Negative 4p and negative 4p is negative 8p plus 1. That's called a square of a difference, and you can also do what's called square of sums. And basically, the only difference between the two is that difference means subtraction and sum means addition, but both can be done the same way. We could find 3x plus 5 to the second power by rewriting it as 3x plus 5 times 3x plus 5, and then double distributing that. So 3x times 3x is 9x squared. 3x times 5 is 15x. And then 5 times 3x, also 15x. 5 times 5 is positive 25. And then combine our like terms. 15x and 15x add up to 30x plus 25. 8c plus 3d squared can be done the same way. I can write that twice because it does mean we're going to take 8c plus 3d times itself. So 8c times 8c is 64c squared. 8c times 3d is 24cd. 3d times 8c, you could write that as 24dc, or that's the same thing as 24cd. So whether it's dc or cd, those are still like terms. And 3d times 3d is 9d squared. And then combine the like terms in the middle. 24cd and 24cd is 48cd plus 9d squared. Notice on each one of these problems, the middle terms were all the same. We had a 24cd plus 24cd, 15x plus 15x, negative 4p, negative 4p. So that leads us to a shortcut. Either whether it's square of a sum or square of a difference, a shortcut for doing this is to just square the first term. So if it's a plus b squared, you can get that by just squaring the first term. The second term is going to be 2 times the a and the b terms, whatever the first and the last terms put together. And then the b squared comes from just squaring the last term. So you can do this either way. You can use it during the shortcut method, or you can just write it out twice and double distribute it. So an example over here, if it's x plus 4 squared, without writing it out separately like they did, we could figure that out by squaring the first term, and that's going to be the first term in your answer. The last term will be the last term squared, so 4 squared would be 16. And then notice the middle term is 2 times the first term, which was x, times 4, which does simplify to 8x. Works the same way with subtraction. So, for example, if we have x minus 3 squared, then that's going to be the same thing as taking x squared. So square the first term, 2 times the terms multiplied together. So that would be 2 times x times negative 3. And that would equal the negative 6x right there. And then square the last term, you get 9. So this is just a shortcut method that works. Makes things a little bit more efficient and fast if you can recognize how to do it and when to do it. So in the next two, I'm going to use the shortcut method. Find the product of 6p minus 1 squared. So to do that, I'm going to square the first term, so that's 36p squared, take 2 times the 6p times negative 1. 2 times 6p times negative 1 is negative 12p. And then square the last term. Negative 1 squared is positive 1. Now this will be the exact same answer as you would get if you were to write it out twice and double distribute. And then 2b, we're going to do the shortcut method on that. So square the first term, so a squared. Take 2 times the first times the second. So 2 times a times negative 2b would be negative 4ab. And then square the last term, which would be positive 4b squared. These look a little bit different. These are called product of sum and difference. And notice it looks like it's the same thing written out twice, but one of them is plus and one of them is minus, which means this was not a set of parentheses squared. This was not a binomial squared because it's not the exact same thing. So what happens if the signs are just different? How does that change how we multiply it out? So if we were to double distribute, I would have 3n times 3n, and that is 9n squared. 3n times negative 2 is negative 6n. 2 times 3n, that is positive 6n. And then 2 times negative 2 is negative 4. And notice that I have a negative 6n and a positive 6n in the middle there. So those actually cancel each other out. So I'm left with just 9n squared minus 4. 4b is similar to that. We have the same terms, but one of them is negative and one of them is positive. So if I double distribute that, I have 4c times 4c is 16c squared. 4c times 7d is 28cd. Negative 7d plus or times 4c is negative 28cd. And negative 4d times positive, or excuse me, negative 7d times positive 7d is negative 49d squared. And yet again, positive 28d cancels out with negative 28d. Didn't mean to completely erase it, just meant to slash through it. So I get 16c squared minus 49d squared. So notice on both of those that the middle terms canceled each other out when one was positive and one was negative. So that's called the product of a sum and difference. So if you have the exact same terms, but one of them is plus and one of them is minus, the shortcut is we just square the first term and square the last terms. We don't have to do the insides or the outsides because they're going to cancel each other out. So recognizing on number 8 down here that we can use the product of sum and difference because if we do the full double distribute, the middle terms are going to cancel each other out. The shortcut method would be just to multiply the first terms and multiply the last terms. So a times a is a squared. Negative 3 times positive 3 is negative 9. So a squared minus 9. Again, that's the exact same thing as you will get if you do the full double distribute. You can check on your own if you would like. And then on this one, we have 2x squared plus 3, 2x squared minus 3. Again, same terms. One is plus, one is minus. So I can just multiply the first terms together. That will be 4x to the 4th power. And then multiply the last terms together. 3 times negative 3 is negative 9.